Day 711 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2,463, minimum total distance traveled. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. There are some robots and factories on the x-axis. You are given an integer array robot where robots of I is the position of the ith robot. You are also given a 2D integer array factory where factory of j is equal to position j and limit j indicates that position j is the position of the jth factory and that the jth factory can repair at most limit robots. The positions for each robot are unique. The positions of each factory are also unique. Note that a robot can be in the same position as a factory initially. All the robots are initially broken. They keep moving in one direction. The direction could be the negative or the positive direction of the x-axis. When a robot reaches a factory that did not reach its limit, the factory repairs the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Return the minimum total distance traveled by all robots. The test cases are generated such that all the robots can be repaired. Note that all robots move at the same speed. If two robots move in the same direction, they will never collide. If two robots move in opposite directions and they meet at some point, they do not collide, they cross each other. If a robot passes by a factory that reached its limit, it crosses it as if it does not exist. If a robot moved from position X to a position Y, the distance it moved is the absolute value of Y minus X. All right, y'all, so that sounds a little bit confusing at first, y'all. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input array robots, and we have a robot at index 0, 4, and 6, and our factory is a 2D. Our factory input is a 2D array. First array is 2, 2, which means we have a factory at point 2 with the limit of 2, and also we have the next array would be 6, 2, which means we have a factory at 6 with a limit of 2 as well. The output is 4. That means we had a minimum total distance of 4. Boom, because we're returning the minimum total distance traveled by all of the robots. Boom, so let's take a look at the explanation so we can see how they got this output from this input. So, explanation says, as shown in the figure, the first robot at position 0 moves in the positive direction. It will be repaired at the first factory. So, this robot right here starts at 0. It's going to move this direction, and it's going to move to this factory right here. Boom. So, and as you can see, this factory has a limit of 2. So, that's going to use one of its robots towards its limit. So, now it has a limit of 1 after we fix this robot. Then it says, and it moved 2 spots. It went from 1 to boom. Then the second robot at position 4 moves in the negative direction. It will be repaired at the first factory. Boom. So once again, this robot is going to go 2 spots, 1, 2 to right here, because remember this factory it only fixed one robot, so it still has enough room to fix this second robot as well. So this moves 2, this moves 2. Boom. Then it says the third robot at position 6 will be repaired at the second factory. It does not need to move. The limit of the first factory is 2, and it fixed 2 robots. The limit of the second factory is 2, and it fixed 1 robot. Boom. So as you can see, this robot is already at a factory, so it doesn't need to move anywhere. So we don't need to adjust the distance for all the robots because this has a distance of 0. Then it says the total distance is the absolute value of 2 minus 0, because we have this 2 and this 0. Boom, that comes from this factory and this robot, plus the absolute value of 2 minus 4, which comes from this factory and this robot right here, plus the absolute value of 6 minus 6, which would be 0, which is this robot and this factory right here. And in total, it can be shown that we cannot achieve a better total distance of 4, and that's how we got 4, because 2 minus 2 is 2. Well, let's just do it over here. So you can see 2 minus, excuse me, not 2 minus 2, 2 minus 0 is 2. Then 2 minus 4 is negative 2, but we want the absolute value, so the absolute value is still equals 2. Absolute value, boom. So we can just bring this over here, boom. And then finally, we have the robot at 6, which would be just 6 minus 6 equals 0, still equals 0, ABS. And then when we add 2 plus 2 plus 0, that gives us 4, y'all. So that's where the 4 comes from. Boom. 4, boom. 2 plus 2 plus 0 equals 4. And that's how we got this 4, y'all. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input robot equals an array of integers 1 and negative 1. Factory equals a 2D array of integers. First array is negative 2 and 1. Next array is 2 and 1. This time the output is 2. Explanation says, as shown in the figure, it says the first robot, the first robot at position 1 moves in a positive direction. It will be repaired at the second factory. Boom. So this robot right here moves 1 position to the right and it gets repaired over here. This factory has a limit of 1. Boom. So it can fit, this robot can fit and get repaired. Then it says the second robot at position negative 1 moves in the negative direction. It will be repaired at the first factory. So this robot is going to move this way. Boom, go one unit this way, and it can get repaired at this factory. Boom. It says the limit of the first factory is 1, and it fixed the first robot. The limit of the second factory is 1, and it fixed 1 robot as well. Or they both fix 1 robot each, and they both have a limit of 1 robot each. Then it says the total distance is 2 minus 1 plus, so that would just be 2 minus 1. That's going to equal 1, which is going to equal 1 ABS. We get rid of this because it's only 2 robots. Then the second robot went from negative 2 to negative 1, which is going to give us 1, or negative 1, which has a value of 1, absolute, and 2, boom. Hold up. Oh, let's clean this up. Boom. Boom, y'all, and that's how we got the output of 2, y'all. So I hope that makes sense to y'all, and now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is we want to sort the robot positions in ascending order. So we'll just say let robots equal robot dot sorted. Boom, put the parentheses. Then we're gonna sort factories by their position. So we're gonna say, we'll come right here, say let factories equal factory dot sorted. Open up the bracket, we'll say $0, square bracket 0. Come outside of that, we'll say less than $1, square bracket 0. Boom. Now we're going to expand factories into individual slots. Each factory position is repeated according to its capacity. So we're going to say, let me see. So it will look something like this. It'll look something like this. We'll say let factory position equal factories dot flat map. Open up the brackets, FN, come underneath this, or inside these brackets, we're going to say array, open up the parentheses, it's going to be repeating, colon, F, square bracket 0, come outside of that, comma, count, colon, F, square bracket 1. Boom, now we're going to use memoization dictionary to cache the results of subproblems. So we'll come underneath this, we're going to create a dictionary, and it's going to be the key. Let's see, we'll come underneath this, let me see. We're going to say declare variable called memo, and we'll set that equal to a dictionary. Sorry, the key is going to be a string, colon, the value is going to be an integer. Then we put the parentheses like so. Boom. Now we're going to create a recursive dynamic programming function. So we're going to say func dp, open up the parentheses, underscore I, colon, that's going to be an comma, underscore j, colon, that's going to be an int, and it's going to return an integer. We'll open up the brackets, and for our base case, all robots have been assigned and there's no cost. So we'll say if I equals robots dot count. We'll open up the brackets and we can return 0. Boom. Then another base case is no factory slots left, but still robots remaining. That means it's invalid, so we're going to return a very large number to represent impossible. So we'll say if j equals factory position dot count, then we'll open up, dot count, then we'll open up the brackets and we'll return int dot max divided by 2. Boom. Then we're going to create a unique key for memoization. So we're going to come underneath this and we're going to say let key equal, open up the quotation marks. We'll say slash, open up the parentheses, pass in I, close those parentheses. Then we'll say pound sign slash, open up the parentheses, J, close those parentheses. Boom, just like that. That should be right. Boom, now we need to return cache result if it's already computed. So we're going to say, come underneath this, and we're going to say if let cached equals memo square bracket key. We'll come outside of that, open up the brackets, and we'll return cached. Boom. Now for option 1, we're going to assign the current robot I to the current factory slot J, and the cost is going to equal the distance plus the result of the next robot and next slot. So we'll come underneath this and we'll say let assign equal ABS, which will get us the absolute value, robots square bracket I, come outside of that, minus factory position square bracket J, come outside of that, we're going to say plus dp, open up the parentheses, we're going to say I plus 1, comma, J plus 1. Boom. Option 2, we're going to skip the current factory slot J and try assigning current robot to a later slot. So we'll come underneath this, we're going to say let skip equal dp, open up the parentheses, I, comma, J plus 1. Boom, then we're going to take the minimum of assigning versus skipping by coming underneath this. We're going to say let res equal min, open up the parentheses, assign, comma, skip. Boom, then we're going to cache the result, come underneath this, we're going to say memo square bracket key, we're going to set that equal to res, come underneath that, and we're going to return res, y'all. Boom, then we're going to start the DP from the first robot in the first factory slot by coming right here, and we could just say return DP, open up the parentheses, 0, comma 0. Boom. Let's go ahead and give that a run. Okay, can I find factory position? So let's see. Oh, should have S. So let's try that again. Give that another run. See what that does. Oh, I did it again. Okay, let's put another S. Let's run it again. Let's see. It's accepted, so let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 2,672 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, before we go, make sure you get one more look at the code. This is the top part. This is the rest of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.